Good afternoon, boys and girls. It's time to go over our solutions for our DMA. So we'll get started with DMA week 31, day 2. So if you look at your 4 problems for today, the first problem has to do with what we've been talking about in capacity for math. So the question asks us to estimate, and because we know that, since it says about, another word that they might use would be approximately. The word estimate is a word that means approximately as well. So it says about how much water will a bucket hold. So since we know something about capacity or volume, we can think about, okay, how do we measure liquids? And in our lessons for this last week in 15-2, we talked about liters. Now, we don't usually measure a bucket of water and the amount of liquid that goes into it based on inches. You could possibly do pounds, however, that would need to be as far as weight is concerned. Now, we do measure liquid in ounces through the customary measurement, but 5 ounces, if you think about a cup is 8 ounces. So our best estimate for a bucket, if you remember correctly, we talked about water bottles, and your 2-liter bottles of soda contain that much soda. So our best estimate would be 5 liters if you use the 2-liter bottles as like a benchmark. So let's go on to our additions our addition equation, and it says 118 plus 853. We're going to take the 2 add-ins and we're going to look for the sum. The sum could be, we could put a letter in there and that would be called a variable, but in this particular case we're going to add. Now there's a couple of different ways that we could actually do this, but we could use our break apart into the different place values. And we would say 100 plus 800 is 900. 50 and 10, when we add those 10s, makes 60. And when we add 8 ones and 3 ones, we end up with 11. Now what does that tell us? Well, that tells us that we are going to regroup that 10 as another 10 to the 60. So when we place these values back together, we are going to have 900 plus 60 is 960, plus 10 is 970, plus 1 is 971. Now, if we were to use our understanding of, let's say, for example, add-on, we could do the add-on strategy. So we could take our largest add-end, add on 100, which would give us 953. Then we could take the 10 from the 18 and add that to the 953, add 10. So now we're at 963. Once we add the 10s place, then we can add the 1s. So we take and add on the 8 more. And 8 and 3, of course, makes another 10. So that would give us 971. So 2 different strategies there. We could also use that understanding to use as an algorithm. So we had started talking a little bit about algorithms. So if we line up our place values, we know that 8 and 3 will give us 11. We put the 1 in the 1's place, and that 10 gets carried over to the 10's place value. So now we have 50 plus 10 makes 60, plus another 10 makes 70. So that's 7 10s. And then we can just add our hundreds, and we add 800 plus 100 is 900. So many different ways to look at this. So let's now look at our fraction. So we are asking if these two fractions are equivalent to each other. So let's first of all determine what the fractions are for these two squares. So the first square is broken up into thirds, and we know that we can use our understanding of unit parts to label each one of these as a 1/3 piece. Now, one of them is shaded, so we have a 1/3 of that square is shaded in. Now, we're going to look at our second square, and we know that it is broken up into 6 equal pieces, because we count all the parts in the whole, and each one of these is going to be a 1/6 part of the square. Now, if we use our understanding of the numerator and count how many of those units, we have 1, 2, 3 of our sixths, 3 of the sixth shaded in. Now, if we think about sixths, it takes 2/6, which would be this part right here, to make 1/3. 3/6 in simplest form is half. Since we can see here that half of this square is colored in, simplest form of 3/6 is half. So when we compare these, we can compare 1/3 and we can compare 1/2. Well, we understand that thirds are smaller parts, unit parts, than one of our half pieces. So we could say that 1/3 is less than a half. So our question asks us, are these two fractions equivalent? No, they are not, because we can use a less than, greater than, or equal symbol to compare these, and we know that 1/3 is less than a half. So now we're going to look at rounding each number to the nearest hundred, and then we're going to add these to estimate. Again, this is an estimation type problem. We're adding, so we're looking for about what the sum of this is going to be, about. So we know that 153, when it's rounded to the closest hundred, we know that 50 tells us to round up if it's greater than 50, or round down if it's less than 50. So the two hundreds that 150 falls between is 100 and 200. It's going to be closer to 200 since our tens place is greater than 50. 117 falls in between the two hundreds of 100 and 200 also. But if we look at our tens place, we know that 50 is our middle mark and 10 is less than 50. So we are going to round this closer to 100. So now when we add these together, we know that 100 plus 200 is 300. So when we do go to add these, our estimate should be about 300. So let's go ahead and do that. So we're going to take the 153 and we're going to find the exact amount to find the sum of those two numbers. So 100 and 100 is 200. 50 and 10 is 60. And 3 plus 7 is another 10. So when I add 200 plus 60 gives me 260, plus 10 is 270. So that's a fairly close approximation. So we're done with our problems for today. We will visit again tomorrow. Have a great rest of your day.